So we've been looking a lot at systems of equations this semester. Pretty important algebra concept. Up here on the board I've got three pairs of equation. So each pair is called a system of equations, right? It takes two or more equations to make a system. So the blue equation, it's got an x and a y. So we know it takes two numbers to solve it. And we know that there's lots of pairs of numbers that will solve this blue equation. So many, in fact, that there's infinite pairs. And if we graph them all, they would make a line. So we call this a linear equation. Same thing happens with the red equation. It's got two variables, so it takes two numbers to solve it. That pair of numbers can be put on a graph. If we graph all the pairs, it makes a line. In fact, drawing the graph is the only way to show all the solutions to the line. There's just too many to list. There's infinite. Like the list goes on and on forever. So we draw the picture on a graph so we can represent the solutions. So solving a system then is finding the one pair, x, y, that makes both equations true at the same time. And we've been looking at lots of different ways to do that. We can graph the two lines and see where they cross. We can use substitution and put one equation into the other one and then solve. Or we could do elimination. We could line up the equations, add them together, and try to get one of the variables to eliminate. But what we're going to do today is see that sometimes the solution to the system isn't always just one pair of numbers. So let me demonstrate. Let's take this first system, and we're going to graph these two equations on the same graph. So I'm going to get this into y equals mx plus b by adding 5x to both sides. That gives me y equals 5x minus 2. You remember how to do that. Now we can put that onto a graph. So let me draw my coordinate plane. This is x, this is the y-axis. All right. Y equals 5x minus 2. The y-intercept is at negative 2. The slope is 5 over 1, so we're going to go up 5. 1, 2, 3, 4, 5 over 1. And if we keep going up 5 over 1, we'll get a line looking like that. All right? Now, we've got our second equation, so we're going to graph the second equation. I'm going to add 3x to both sides. It gives me 6y equals 3x minus 12. And then I need to get rid of the 6 by dividing everything by 6. Y equals 1/2 x minus 2. So I go to graph this. The y-intercept is at, oh, look at that. It's the same exact y-intercept as the blue equation. And the slope is up 1 over 2. So that's here. I get a line like this. But I kind of got lucky with this system. I actually set it up that way to make it easy for us. Makes for a nice example. Here is the solution to the system. Right there at 0, negative 2. In other words, that is the one point that makes both the red equation and the blue equation true at the same time. The blue equation's got all infinite solutions on the blue line. The red equation has infinite solutions on the red line, but there's only one solution that they both have in common. That's the solution to the system. Now, does that always happen where you have exactly one solution to the system? Well, all the examples we've been doing the last couple of weeks, we picked examples where there was that one point. And they were both integers. You know, we didn't give you any ones that were fractions or decimals, but in the real world, you're going to probably get some fractions and decimals, but we kept things easy for us because we're just learning this. Let's go on to the second example here. What's going to happen when I graph this one? Okay, so let me get this into y equals mx plus b. So I'm going to subtract 3x. And I get 2y equals negative 3x plus 6. Then I have to divide by 2. And I get, I'll write it over here, y equals negative 3 halves x plus 3. 6 divided by 2 is 3. Okay, so we can graph that. Let's draw our coordinate plane. And we have our y-intercept at 3. Our slope is down 3, right 2. See the negative 3, down 3, right 2. So down 3, right 2. Okay, let's move to our red equation. I'm going to get it into y equals mx plus b. All right, divide by 4. Y equals, well, I can reduce negative 6 over 4 to negative 3 over 2, and 8 divided by 4 is 2. So my y-intercept is at 2, and my slope is down 3, right 2. So down 3, 1, 2, 3, right 2, 1, 2. So where do these two lines intersect? Well, they're not going to intersect. They're parallel. They're going to run the same distance apart all the way towards negative infinity and towards positive infinity. So there is no solution to this system of equations. The blue equation has infinite solutions. The red equation has infinite solutions, but they never have the same solution. And we know this was going to be true as soon as we got to this step. The same exact slope, but different y-intercepts. Same slopes, different y-intercepts. Okay, so they're going to start at different places on the y-axis, but they're going to have the exact same slope, so they're just going to run side by side. No solutions to this system. Okay, here's the third example. And you probably know where this is going, but let's finish up the problem. So I'll subtract 2x from both sides. That gives me 3y equals negative 2x plus 12. Let's make that look like a y. And then divide everything by 3. That gives us, I'm going to write it over here on the side, y equals negative 2/3 x plus 2/3. Oh, I made a mistake here. That's 12 divided by 3 is 4. So this is a 4 here. There we go. Y equals negative 2/3 x plus 4. Well, before I go and graph that, I'm going to go ahead and get this one in y equals mx plus b. So subtract 4x, get 6y equals negative 4x plus 24. Divide everything by 6. Y equals, let's see, negative 4 over 6 reduces to negative 2 over 3. And 24 divided by 6 makes 4. Well, would you look at that? They're actually the same exact equation. So if I go and graph these, you're just going to end up with the blue line and the red line on top of each other. So our blue line, the y-intercepts at 4. The slope is down 2 over 3. There's our line. And the red line, the y-intercepts at 4. We go down 2 over 3. And you get exactly the same line. So how many solutions do these two lines have in common? Well, they have all their solutions in common, so they have infinite solutions in common. So those are the three things that can happen when you're solving a system of equations that has two equations. You can get one solution, no solutions, infinite solutions. So today you're going to watch some Khan Academy videos that are going to help you with this concept, and then do some exercises where you're kind of going to play a game where you have to guess by looking at the equations, am I going to get one solution? Am I going to get no solutions because they're parallel? Or am I going to get infinite solutions? And just think of it as a game, and then it'll bring a little bit of fun into your math work today.